In last lecture, we had the discussion about the basics of encoders, wherein we discussed that encoder is a digital circuit in which we can have 2 raised to power n number of inputs and n number of outputs. So based upon this, we can say that here number of inputs equal to 4. For the basics of the encoders, you can go through the previous lecture, the encoders and introduction. So from there you can get all the basics of the encoders, but because now we are designing 4 to 2 encoders, so we will not discuss about those basics that we have already done. So here the number of inputs are 2. It means 2 raised to power 2, and we name these inputs as say y0, y1, y2 and say y3, and number of outputs we will have 2, because 2 raised to power n if number of inputs, then n will be the number of outputs. So 2 outputs, and we name it as a node and a1. Okay, so the block diagram, this is the first point, the requirements. We can say that these are the requirements. Second thing is block diagram. Block diagram means we have this is say for example 4 to 2 encoder, where we are having 2 outputs, A1 and A node, and how many inputs? 4 inputs, and we are naming it as y3, y2, y1 and y dot. The order is your choice. You could either write it as y node, y1, y2, y3, a node, a1. The choice is yours, because this is just the naming conventions, and there is nothing to remember about all these things. You can name in any order. So by seeing the block diagram and according to the definition of the encoders, we know that at any time only one of these 4 inputs, can be high, means 1. That is only one input. In previous lecture of introduction about encoders, we also discussed same thing, that only one input line is active at a time. So this means this actually. So we also know that this encoder also performs the reverse operation of decoder, because decoder takes if 2 number of inputs, then produces 4 number of outputs. So this is the second point that we must note. And about the third point is its truth table. In truth table, you know that primary requirement of any truth table is number of inputs and obviously the number of outputs and the combinations of those things. So this is input and this is output. Inputs can be y3, y2, y1 and y0, and outputs can be a1 and a dot. So because only one input can be at active high, so first you consider that this is high. Now consider this one is high. Now consider by2 is high, and now consider by3 is at a high value. Okay, based upon these inputs, actually based upon these combinations of the inputs, we can have output. If y0 is equal to 1, then it is 0 0. If this is, then 0 1. If y2, then 1 0, and if y3, then 1 1. So this is input function and this is output function. Now the fourth point that should be about the logic expression. Actually, the format for designing any digital circuit is very much same. First you write down the definition part that we discussed, then draw the block diagram and some information about the block diagram. Then third point is the truth table. Fourth point is its a logic expression, and based upon that logic expressions we can have the circuit diagram. So these just are the points that you need to remember in a sequence so that you can design any digital circuit. So for logic expressions for A1, because we have two outputs A1 and A0, see the A1, the values of 1 at this point and these two ones. So see the corresponding ones. 1 here means y2 and 1 here, this is by 3. So I can write it as y2 plus y3. Again see, first see A1, where are the high values, 1 and 1. Then see corresponding inputs, y2 is 1, so y2, and y3 is also 1, then y3. And same way for A node, the logic expression for A node, see two values, 1, this, it means y1. Now this is also 1 corresponding to this value, this is y3. So this is the logic expression for two outputs. And based upon the logic expressions we can draw its circuit diagram. See, we are having 4 inputs, y0, y1, y2 and y3. These are 4 inputs. Now we are having one OR gate here and one OR gate, 2 OR gates we require actually. So we are taking one OR gate, this is for say A1, and one another OR gate, and say for example this is for A0. So for A1 by 2 plus y3, and this is y2 and this is by 3. So 2 inputs for this. So this comes out to be y2 plus by 3 A1. Now for A0, the value is y1 plus y3. So y3 is here, so we can directly have the line from here, and y1, so y1 we are having here, so this is y1. So we can have a node as y1 plus y3. So overall, if I consider it as a block, see, if we consider it as a block, then this block is same here, where 4 inputs and 2 outputs. Internally, this is the circuit diagram. And also that if we want to check it, then obviously we can check the circuit diagram also. So if we check it, then say for example, if y1 is equal to 1 and rest of inputs are zeros. So name it as 1 and 2. Then obviously you see from from A1 we are getting, this is 1, so 1, this is 0, so a node is equal to 1, and A1, because we are taking y1 is 1, so and because in 1 there is no connection from y1 actually, so the output from A1 is equal to 0. It means that when y is equal to 1, checks, when y1 is equal to 1, the value of A1 is equal to 0, the value of A1 is equal to 0, and the value of a node is equal to 1, and value of a node is equal to 1. So this is the way how 4 to 2 encoder works. Thank you very much.